Alright, say we wanted to determine the instantaneous rate of change for the function f of x is equal to 4x squared minus 4 when x is equal to 4. Okay, now one way we can do this is through something called a small interval method. Okay. Now, first we need to kind of define what is a tangent, right? And what is the instantaneous rate of change. So let's say that our function kind of looks like this. And we're trying to figure out, the instantaneous rate of change at a single point, right? Now, instantaneous rate of change is going to only occur at a single point. It's not going to occur over an interval. That's the average rate of change. And when we're looking at the instantaneous rate of change, we're actually going to be looking at the slope that only touches that one point. Now, this line here is called a tangent. And the slope of the tangent is your instantaneous rate of change, right? Now, the problem here is finding the slope of tangent, really what calculus is all about, right? We're going to kind of investigate this later on, but there are multiple ways to do this, and I'm going to show you one of them. So it's called the small interval method, right? Technically, if you take an average rate of change, like a secant, right, and you shrink it smaller and smaller, and you make the interval close to 0, you eventually get to a tangent. Now, when we're looking at a small interval method, ideally we want to take a single point and we want to look at creating a small interval that encompasses that point. Now, usually when you're looking at this point, we can make a small interval using x plus minus 0.01. A more defined interval can be created by x plus minus 0.001. Okay, so this is how we can create a small interval. And when we create an interval, it's always between a lower limit and an upper limit, right? So I'm just going to kind of use this approximation, right? Because technically it'll give us really the same answer. If I use this approximation, and this is an approximation, if I use this approximation, the lower limit here is 4 minus 0.01, so that's going to give us something like 3.99, and let's call this the lower limit, and the upper limit here is 4 plus 0.01, which is going to give us a value like 4.01, right? So this is the upper limit. And technically our small interval is going to look like x is greater or equal to 3.99, but less than or equal to 4.01. Okay, so that is our small interval. And now when we have our small interval, at this small interval, the slope of the secant can actually be approximated as the slope of the tangent. So that's really the idea behind it. Now, if we're finding the slope of the secant, well, we know that the slope of the secant here is f of x2 minus f of x1 over x2 minus x1. Okay, so we'll just use the rise or run formula that we did in previous videos. And in this case, f of x2 here is, let's say x2 here is the upper limit, so let's say it's 4.01. So if I do f of 4.01 is basically 4 times 4.01 squared minus 4. Just going to calculate that out, and I get 60.32. Then I'm going to do f of 3.99, and I get 4 times 3.99 squared minus 4, right? Whoops. And if I punch that out, I get 59.68. And if I plug this into my function, right, f of x2, that's going to give me 60.32 minus f of x1 is 59.68. And divide this guy by x2, which is like 4.01, minus x1 here is 3.99. Okay, and if I calculate all this out, I end up with 32. Okay, and that is actually the slope of the tangent at that point.